We're in a world where software isn't just black and white anymore. We're not talking web app versus desktop app anymore. We're in a world spewing with terabytes of data and interconnected devices. We're in an event-driven world, and it's time we start building event-driven applications. In this kind of world, it's hard to fathom building a web application that will merge with the desktop and the mobile. And we need to manage events that let specific applications deal with the outcome of those events. We're going to show you how to do this today using Azure Functions. And my name is Maxime Rouillet, and I'm a cloud advocate at Microsoft. To build software in this event world, we'll need to talk about how we implement code that reacts to those events. We call them triggers. Then we're going to look into the architecture that is adapted to an event-driven scenario. When things are happening so quickly and you don't need to be real time, it opens up the gate for workflows. How do you create beautiful experiences in this event world? And finally, we'll need to ensure that what we build stays up to date and consistent. We need to talk about operational best practices. So let's get started. Events are happening all over the place. By removing the veil, we start to notice that so many things are just events happening at a massive scale. Whether it's a server rebooting, a file being uploaded, or somebody's phone going in and out of a geofence, they all can trigger code execution. Notice that word trigger again that I used. It comes naturally in why we are using it. Triggers can happen on a predictable schedule, like when you're running our timer triggers, or completely unpredictable when you're running an HTTP API. Triggers are events that trigger code execution. For us today, it will be an Azure function. That code that can be written in a multitude of languages, C#, Node, Python, or many more, are just a few of the many languages for which we support. Those functions all have something in common, and it's a trigger. What they may want to do, however, is to create an output. Once you're done executing a piece of code, you may want to have the result of this execution persisted somewhere. This is just what an output do. And maybe you don't want to store the value itself, maybe you just want to trigger another event. In this moment, you've just created interconnected pieces of code that can scale to infinity without being explicitly aware of each other. Event-driven architecture blows my mind with awesomeness. Gone are the days when we were only building APIs and desktop applications. Let's get started on a demo to show you the potential of functions. We're going to start with something simplistic and ramp it up. So in this demo, we're going to cover event grids and Azure Functions. So let's start with Visual Studio. We're going to start with an empty Azure Function application. And the first thing we need to do before we even get started, especially if you've never used Event Grid before, is we need to install the proper package. So let's just look for Event Grid and install the Microsoft Azure Web Jobs Extensions Event Grid package. The latest stable is going to be fine. And the reason we're doing this is if you've never run Event Grid before, the Azure function will not know what extensions are available. So this is kind of an opt-in model, because otherwise in the past we used to have all the events all into Azure Functions all packaged up, and it tend to be a little bit large, especially if you're not using them all. So in our case, we've just installed Event Grid, so that's going to turn it on for our application. So let's do add new Azure function, and we're going to call this, instead of function 1, we're going to call this event handler. We're going to pick an event grid trigger, and this will use the existing template here to create an event. And the only thing we're going to output is the actual data of our event. That's it, nothing else. So now let's right click publish. So we need to start publishing this application. So where are we going to publish it? So we're going to publish it to Azure. Let's do next. And there's going to be a Windows application. We don't need to do more than that. And since I'm already connected to my Azure function and my Azure subscription, it's automatically going to pick up the right subscription. It's going to offer me a few views. I have an event demo here that I want to do. Let's take this one. We're going to finish. The run from package at the bottom that was just right there will allow us to basically just zip the application altogether. And then we're going to click on publish. So what is going on here? So let's look at the output. First is going to establish a connection to our Azure Functions, and it will start to build our application using the .NET Core compiler. Azure Functions, in our case, we're running the latest 3.0 version. That's what we want to run. This is the latest version. You should be on it. It's only going to be better going on from here. If you're still on 1.0, migration is kind of required at that point. 1.0 only use .NET Framework, and the move for .NET has been to be more focused around .NET Core, which is more cross-platform compatible. So you can run Azure Function in containers, but only if you're running from 2.0 to 3.0. In our case, we're running 3.0 because it's the best version. So here, let's look at what happened here. We can see here that the event app created our DLL, created things in pub tmp out, but then there's publishing, and we can see here that it published a zip file directly onto Azure. So now that our application is deployed, we need to actually look into the cloud and see what are we going to do with this. So our demo already had a storage account. However, the basic storage account that is created was V1. So I already created this one, which is a V2, a storage V2. And the things that I want to do is I want to hook events to this. I want to make sure that every time something happened in our storage, that our Azure function reacts to it. So let's get those two connected together. So you get into events, and then you have a choice. You want to do logic apps, you want to do Azure Functions, or there's even more options, but Azure Functions sounds cool. Let's do this and do create. This will take you to our Azure Functions, or yeah. So if you were to click here, it would be creating the application directly. So what we want to do is we already have an Azure function that we're going to be using. So let's click on Azure Function here, and we're going to use a storage events. And the schema does not really matter here. And what I want to do is I want all the events. All of the events, I don't care. I just want all of them. And then I'm going to choose an endpoint. And the endpoint I want is Azure Functions. I can do select. And it's automatically going to look through my resources. And basically the resource group I'm in right now is going to see if is there a function in here that it could deploy to. And of course, yes, there is one. Then it will look at the available slots and find that there's an actual function here. So if there were more than one, it would show up here. So let's do confirm selection and click on create. So here you can see the status of our event subscription deployment. Of course, it is very fast. But thing is, how do we know, like, so let's go into our Azure Storage Explorer. And this is my proper container. So let's do create a blob container, and I'm going to call this my pictures or my photos. There you go, my photos. So this is going to be fine, but if I upload files, and so I have a good collection of Bing images that I really love. So let's upload 3 of them. And I click upload. How do you know if those events has triggered after we're done uploading those files? This is serverless, so we don't know which servers it runs on. We uploaded those 3 files, but we don't know if the function is actually called. So let me show you how you can do this. One of the many ways to see if this connection has been established properly. So we have our function, but I want you to look into Application Insight. So this is not a demo about Application Insight, but it's definitely something you want to keep a track on, and you want to have enabled on all of your serverless application all the time, because it allows you to basically see what's happening in your application. And with serverless, with so many servers, we don't know what happens. As you can see here, there were a few requests that had just happened. Let's look at live metrics. This is probably one of the best features of Application Insights when you're connecting it with Azure Functions, because it allows you to see on multiple servers what it runs.
And this is totally amazing. So we can see here we actually have 3 servers. We're not paying for those 3 servers, of course, but we're paying for the function and where it runs. So you know what? We have sample telemetry here, but let me just re-upload more pictures. We need more pictures. So let's select more files, and we're going to upload a good bunch of them. Maybe too much for this demo. It's probably going to be slowing me down, but you know what? We're doing it for science. So while this is uploading, the transfer is happening, we're going to see things happening here. And all those different sections here are going to start popping up. So we will see the amount of incoming requests. We can see here that we have 3 requests per second, things that are happening here on the cloud. And as you can see here on the left, on the right, you will see here, oh, there's trace, there's put blob that happened. Let's take a look at that. Those are events that are interesting. You can see the request ID here. You can see the content that we uploaded an image, and there's a whole bunch of information about this. And all of this, like, we know those requests came in. We know those things were happening because we executed event handler and we know the content of that file. So we know everything that happened here in all the other 18 events. We know the request duration. How long does it take for us to execute this Azure Functions? What is our failure rate? What is the amount of memory we're using? What's the amount of servers we're using? We have 6 servers online right now. We don't know there are 6 servers, but we know that all of this ran on 6 servers and it was successful. All right, so that was just a basic demo. So let's go back to our slides.
Here are a few potential events that we have built in within Azure. Don't forget that you can make your own. The demo you've seen is obviously simple. However, there are other potential events that you may want to look into besides storage. Key vault is one where its usefulness into an organization is very high. It is essential. Gone are the days where you won't know until everything breaks that certificates, keys, and secret are expiring or has expired. Azure Maps. It allows you to handle users going in and out of predetermined regions, something that is called geofencing. What do you do when Fluffy the cat escapes yet again your home and goes off running? Or maybe you're maintaining a lot of containers and you need to run some logic. When images or Helm charts operation happens, well, this got you covered as well. Finally, at the subscription level, it's possible to run code that will react to resources action, whether they succeed or not, so that you know the next time somebody tries to create a monster VM or something else. And don't let any of this stop you, however, because if you can't find what you're looking for, you can build your own events and react to them accordingly using Event Grid. With this eventful world, there are processes that are not simply streamlinable into a single piece of code. There are business processes out there that can take hours, well, more like days to finish. You can't simply put a serverless function alive forever while waiting for user inputs. First, at some point, the execution is going to time out. And second, you get charged for what you're using. So the time you spend waiting is being charged as well. This is indifferent of whether you're just waiting or are actively processing data. So let me show you how durable functions can make complex processes like this simple. Here's what a durable function looks like. There are 2 core concepts in durable function that we must know. First is that an orchestrator function works by having an durable orchestration context, just like so. This defines an orchestrator as the only function that can invoke other function. Talking about other functions, we're calling them activities, and they can be called by using the call activity async. They are single unit of work that are only callable from an orchestration function. There are a few things we need to be aware of before we set off into this adventure together. Orchestrator function should never run non-deterministic code. That's a $5 word, right? Non-deterministic. Well, it's quite simple. It only means that a function that is non-deterministic means that the result is not the same every time you call it. So if you generate a random number, you retrieve the current date or current time, those are non-deterministic. Things like reading from the disk, reading from a network, those kind of things should not be into an orchestrator function because they are non-deterministic. They're not guaranteed to return the same result. An orchestration can have its execution suspended and resumed, meaning that it will have to run through those bits of code again, and if they return a different result, it can get extremely hard to debug. Same thing goes for any I/O operation like network or disk, like we just talked about. Those should not be run into an orchestrator, but within an activity. Now, those activities are part of an execution history that is event source. What that simply means is we're never going to run an activity twice. We'll store its result and return that result when the orchestrator replay. So why does that matter? Because we've been building serverless application as stateless. This is stateful. We know where we are in our execution steps, and we don't need to save the result ourselves to prevent calling a service twice. The framework does it for us. So let me show you how it works. So first, we're going to start an orchestrator, and the function is going to start and going to go through the code. The first thing it's going to hit is our call activity async. It's going to schedule an activity to be run on this, but before it does that, it will first look into the execution history. Did we run that function before? The function say hello with the parameter world. Did we run that? And the answer here is no, we did not. So the only logical thing to do here is to actually schedule the activity to be run with those proper parameters. But then there's nothing else to do. We need to wait for this function to finish. So the orchestrator is just going to complete for now. Eventually, the activity function will get resynchronized and resynced and ready to be invoked. So this has been scheduled with a proper parameter. The function is going to run, and hello world is going to be the output of this function. And once this is done, the orchestrator is going to get rescheduled to be re-executed from the stop. But now, again, it will look into the execution history once again, and this time, our activity has already been called. So we already have hello world as a parameter. So it can proceed to the outputs and return the result. So the orchestrator now would have completed its execution and completely finished its whole orchestration, and now we're ready to return all the result of all this. That allows us to build amazing pattern in complex flows that we're jumping onto next. In the function chaining pattern, our sequence of functions execute in a specific order. In this pattern, the output of one function is applied to the input of another function, like we can see here. In this scenario, F2 takes the result of F1 and passes it as a parameter, which will become Y, which is going to be passed to F3, and so on until this whole orchestration is completed. In the fan-out, fan-in pattern, you execute multiple functions in parallel, and then you wait for all functions to finish. Often some aggregation work is done on the result that are returned from the functions. So the difference here is that, as you can see, call activity async for F2 is not a wait. We're not waiting for it. We're just queuing them up and adding them into a list of parallel tasks. We wait for all of them to complete with the await task.whenAll. Similar pattern is also available in Node using the yield parameter. The async HTTP API patterns address a problem coordinating the state of long-running operation with external clients. A common way to implement this pattern is by having an HTTP call trigger the long-running action, then redirect the client to a status endpoint that the client polls to learn when the operation is finished. So in our scenario, we're going to start a new async, and just a little 2-line below, we're doing a starter.create check status response, which will allow the user to just poll Azure durable functions for updates on our process. The monitor pattern refers to a flexible, recurring process in a workflow. An example is polling until specific conditions are met. You can use a regular timer trigger to address this basic scenario, such as periodic cleanup job, but this interval is static, and managing instance lifetimes become complex. You can use durable functions to create flexible recurrence interval, manage task lifetime, and create multiple monitor processes from a single orchestration. As you can see here, we're using the date time, but we're using the date time coming from the context. We're not using things that are non-deterministic, that will return a different result every time. And we're using a special create timer here to do the same operation for the monitoring. Many automated processes involve some kind of human interaction, and involving humans in an automated process is kind of tricky because people aren't as highly available because they kind of need to sleep, or not as responsive as cloud services because they kind of need their personal time. So an automated process might allow for this by using timeouts and compensation logic. So what we're seeing here is that we're going to create an external event, and that is the approval event, and we're going to wait for that external event. But we're also going to have a timeout, and we're going to wait until either one of those finish first. And we're going to try to figure out if that event was either the approval event or the timeout event, and we're going to go from here following the workflow. The sixth pattern is about aggregating event data over a period of time into a single addressable entity. In this pattern, the data being aggregated may come from multiple sources, may be delivered in batches, or may be scattered over long periods of time. The aggregator might need to take action on event data as it arrives, and external clients may need to query the aggregated data. The difference here is that we're using something called durable entities. That is part of durable functions. You can see it here. It's still going to provide a context. This one is an entity context, but the only thing that it's going to do is going to do a dispatch async in this case. There is not a lot of logic happening here, but what is going to happen is it's going to serialize the whole entity as an object and save its value. And that's pretty much all it does. Here's a demo that was built to analyze data on a popular site. In this example, we're using a Chrome extension that uses the async HTTP APIs pattern coupled with the chaining pattern. Let's go through how it runs and read the orchestrator function together.
All right, so in this demo, I'm going to talk about the Reddit emotion analyzer that I built. It will take the first 200 comment out of a Reddit thread and generate an average emotion for Reddit posts. So all these three requirements are right here, and I'm going to share this link a little bit later. So you will need the latest version of .NET Core if you want to run this. You will need also an Azure account. You will need to create a cognitive services text analytics service. And of course, you will need to have some basic configuration in here. This button will deploy everything that you need and get your application ready to run. So all those instructions are here. So how does it work? Because it's way more fun to see an application run and see the results than just see like a README of a GitHub repository, right? So let's open up Reddit, and I have this extension already preloaded. This is a non-package application, so this was just loaded straight from the code. So I'm going to click on it, and we're going to see here that it is starting, and it's running, and it's going to return me a result. All right, if I click on it again, we'll see starting and boom, returning automatically. So this thing kind of has two running mode right now, but we see in general that on this post, everything is pretty much positive. There's very little negative. There's a lot of neutral and mixed comment, but overall, I feel very safe going into this thread. So let's see how this thing works. So how do you actually know that this thing has run, right? Well, I've enabled the live metrics on this application as well. So if we look at everything that happened before, let's just do it again. Just start it and start looking right here. You will see that we have incoming requests and we're handling all those automatically. All of this has been handled in mostly less than 500 milliseconds and probably less than 250. There was no request failure, a little bit of failures on the dependency call, but this was handled very nicely. And we see that the processor here is pretty low. So all of our application is working just as expected and it's returning results. So let's look at the code. So let's start with our extension. Our extension is just a simple pop-up.html that just call this code and loads it up automatically. So pop-up.js, just invoke my API and retrieve the status query get URI that is being given by durable functions. This is a status endpoint for us to retrieve data whether this durable function has completed or not. This is very essential for me because I'm going to be polling this every second. We can see this. This polling is going to happen at set interval right here, and it's being set at 1 second right here. Now, what about the code? There was a whole bunch of code, and this is based off of this thread where if you had anything .json at the end, you pretty much get a massive amount of JSON file. And we're not going to dwell too much into the data structure, but mostly what happened here is this piece of code is going to be invoked. So HTTP start is going where our code is going to come in. This is our basic HTTP API for which we're starting our application. Mind you, durable function does not need an HTTP API to start a process. Think of this as anything else, like any event can start an orchestrator. Whether it is a new message, a new file that is being uploaded, or a certificate that is expiring on your key vault, or somebody like Fluffy the cat getting out of the jail fence. We need to have an event before we can trigger our orchestrator. And in this case, we only need the iDribble orchestration client, just like we saw a little bit earlier in our slides. Once we have this, we're just creating a URL, and then we're starting a new thread asynchronously. Then we're going to run the orchestrator, and that is the piece of code that I want to show you. We don't need to really look at everything else, but this one is actually the most important one because it will structure entirely everything that is around our code. So this is going to define how our code is going to run. So let's take a look at it. We're going to take first the rated JSON URL and retrieve this value. The existing result then is going to get called, and we're going to get this call activity async to see if do we have processed this in the past. The reason for this is running on a cognitive services that is a free tier. So I don't want people to just call that API and just exhaust all the resources. So this is not a process that you need to do every time. But for me, since I wanted to make sure that I'm kind of caching this result, that it's not going to get abused. So if we don't have any existing result, then we're going to process the rest. But otherwise, I'm just going to return the result I already have. At this point here, you can add any kind of conditional operator here. Is it too late, or is the caching value has been done like more than 24 hours ago, more than an hour ago? You can change those conditions quite easily. Then I'm going to be using the new call HTTP async parameters that are available in the newest version of Azure Functions, which is just going to invoke the URI with an HTTP GET and return me the content. So that's what I'm going to do here. And then I'm going to use a function to parse all the comments, because since the comments are technically recursive in nature, you can have comments of comments of comments ad infinitum. Basically, at this point, what I want to do is I want to parse them all. I want to make sure that I have all the comments, all in a nice list. And I want to make sure that I have a list with their ID so that I can just parse them out and send them up to be analyzed. Finally, we have this call activity async here, which is going to call the Analyze in Motion API for cognitive services and return a result. I could have done a fan out, fan in pattern and invoke the API for each and every comments, but the cognitive services API offer a batch operation, so I'm taking advantage of that. And finally, once I have the results, I want to make sure that I am saving them, because otherwise line 56 is not going to be able to skip this invocation. So we need to analyze that. So I'm saving those results. And at line 66, I am returning them. So what's going to happen here is that once we have the result of our operation, the orchestrator is going to complete with this result. So the status query API that we have, which is around here, the status is going to return the result of the orchestrator all the time. So as long as the orchestrator is still running, we're not going to get any new result. So let's run this application again with this context. So if we click here, we'll see that it's starting and it's going to return the result automatically. So let's look at our storage and refresh our page here. So we see here that we have our element and we see the results. Mix 23.29, close enough. The process date, the positive, the timestamp, everything is here. And we're not updating it. If I delete it, then what's going to happen if I refresh it, it's going to run this time. It's not going to recache it. So I can reopen this page again, refresh, and we're good to go. So with this process, you can run any kind of durable functions on your side of the code, any kind of process that requires those more complex workflows. This is available for you with really, really simple code. This is what we're seeing here.
So let's be honest here. Hello World has never convinced anyone that a technology had merit. So how do you make this real? There are multiple samples available online about serverless and more complex workflow. So let's start with this first example that I talked about, renewing secrets with serverless code. This example is using the same event grid we talked about earlier in Logic Apps to do something similar than what function could, just with less amount of code. Then there's this sample here where you can use a storage event like we use today to feed images into a machine learning model. This sample is the one you want if you are into big data. It uses durable functions to apply a map-reduce pattern at serverless scale. MapReduce is just a way to aggregate data out of a very large data set. It uses the same pattern that we used earlier called fan-out, fan-in. Then this sample was built by Anthony Chu and creates a live multilingual auto-captioning application on top of SignalR and Azure Functions. That's right, you can get real-time captioning of your voice as you're talking by just paying the price of Azure Functions, which is basically almost free, and SignalR. This sample was built by me as a way to aggregate data out of GitHub. It uses the chaining and a fan-out, fan-in pattern. It's definitely a must look if you're really interested in durable functions. Finally, this last sample uses HTTP APIs and Event Hub triggers to build a game telemetry visualizer. This is one of the coolest demo I've seen. And all of those samples uses one or many of the patterns we talked about today. With our application well ahead of being deployed, we need to talk about some operational best practices. Our serverless application has many advantages, but it has the same operational requirement that any other application you deploy on the cloud. We're going to go through a few of those similar requirements as well as others that are especially needed within the serverless application. And finally, we're going to complete a session by enabling a CI/CD pipeline for our application. All of Azure Functions relies on the same foundation as App Service, or Platform as a Service offering, and can thus use Azure Active Directory in its B2C part for operation on your resources. I can't stress enough the requirement of using things like managed identities and Key Vault. It's the best way to keep your API keys, certificates, and most of your secrets under a strict lockdown. That recommendation is for both functions and your standard application. If you want to know when everything is working as expected, or if everything is working as expected, we need eyes and ears within our application to notify us when something happens. We saw this earlier by using live metrics with our Azure function. No matter how many servers or code was running, it would have the same centralized logging system. Much more can be done with Security Center and Azure Sentinel, but that'll need to be left for others to show. Then we're left with networking and on-prem access. Function work with all those technologies as well to either limit or enhance access to your application. And I would recommend into looking to those different options for you. There are multiple ways to get your code into the cloud. The very first is to directly publish from your editor of choice. In the Visual Studio world, we call this right-click publish. But let's not talk about this because, well, as one of my friends says, friend don't let friends right-click publish. Another option is called Kudu. Kudu, while they sound appealing, the fact that it runs on the machine that is executing your code right now implies a lot of possible issues and lack of features.
So let's not run into Kudu right now. Let's use something that is external to our application and that is not dependent on the developer machine. So the best way for me to publish our code is to use something we call a CI/CD tool. CI/CD stands for continuous integration and continuous delivery. There are many platforms available, and we also have our own. Everyone has seen the classic Azure DevOps demo by now. So you know what? Let me do something with Azure GitHub Actions. We're going to take this code, pull it from GitHub, run a GitHub Actions, and take it into Azure Functions. So what I want to do is to show you how to do it with GitHub Action, right? Although not as full a feature as Azure DevOps, it will give the power of continuous integration to all developers quite easily. All right, so in this demo, we need to take our application that we built earlier. So the one that was here, the event app. So what we're going to do, we're going to start with git ignore. The first thing I want to do here is add this publish profiles. Since we used a right-click publish earlier, that means that there's a whole bunch of different stuff that are available here, including password and information that we don't want to have in our repository. All right, so let's start by creating our repository. So we're going to call this the event handler function app. That's it. We don't need any template. We don't need anything special. We're not adding anything special here. We're doing a create repository directly, which is going to take us to this beautiful thing. So we don't want to create this, but we do want to do a few of those steps. First thing we want to do is open up Visual Studio. We're going to go into View and Terminal. Mind you, you could also do this into a standard bash or standard PowerShell prompt. It's not a problem here. So we're going to git init this repository. So every time I do a git init, I love to do a git status to see what am I doing here? What is happening? So since we already have a git ignore for this file, we're going to just do a git add to add all the files. And we also want to git commit this with an initial commit. All right, so we can see here exactly which file we added. And as you can see, we did not include the publishing profile, which is amazing. Then we need to make sure that we sync up this repository with this one. So we need to do a git remote add origin, the same thing that you see here. So let's do this command and paste it right there. We're going to enter it right here. So what happened here is that we set up this remote repository as our source, basically where we're going to store this data. It's a remote. But now we need to push the local code on a local machine to this remote. So what this will do is that it's going to merge this origin, this remote, in our master branch. They're going to mix them up together. They're going to set them together. By doing this, it's going to upload the code. And as soon as this is done, by going back here, we can refresh, and our code is going to be done. All right, now the next thing you want to do is we need to set up our branch. So we need to set up an action. So as you can see here, there's not an Azure function available right now. So what you can do is just go on github.com/azure/functions action. There are multiple templates depending on where you want to deploy. In our case, we're going to be using the first one. I already opened it up in a raw right here. And I'm going to copy paste that into set up the workflow yourself. So it can be called main, it doesn't really matter. Let's just paste the whole file here. Your app name, all this is not necessary in our initial scenario. However, there is a single thing here that is very, very important. Tell us to set up the publishing profile. How you do that is we're going to open up the settings in a different tab. And we're going to go into secrets and add a new secret and paste that in there. So one of the things what we need to do is we need to get our publishing profile. And this publishing profile, I'm going to copy paste it here. And I will delete this application after this is recorded. But so you will not be able to see what was just pasted right here. But you can get the same publishing profile for you on your side by going to your Azure function right here. And at the top, you will see right around here, a little button that's called Get Publishing Profile. This publishing profile is an XML file that contains all the necessary information for you to publish your application. So what we just did is that we set up this secret that will be able to be used by GitHub Actions. So now that this has been done, we can just close that up and we can go back to our file. We can review a little bit the builds that's going to be done here. So we have a build and deploy. It's going to run on Windows. It's going to use a few actions. It's going to use checkout. It's going to use .NET. It's going to use a whole bunch of different stuff. So this is pretty much all good. So we just need to do a start commit, and we're going to commit this new file. So at that point, like, what is going on, right? So we're going to look into our actions, and we see here create main.yaml. We can click on this to get more details. We can click on build and deploy to get even more details. We see here that this has been queued up. So this is going to set up the job. It's going to download a whole bunch of different stuff. But this is going to take about 2 or 3 minutes to run. So I just want to look into the GitHub function here, this little piece of code that we deployed. We picked up the raw version for copy pasting value, but if you open it up just in GitHub, it shows you a way better version. So there's a few things here that we need to understand. So env here are environment variables. They don't need to actually be exactly the same as what you see here. They can be anything you want. But the main one is here on push. This will determine what kind of trigger will launch your build. There are many of them that are available, but for us, every time we push new code, we want to make sure that we create a whole new build. Then the jobs here are going to be determining like what we want to run. So basically this one says, this one's going to run on the latest version of Windows, and here are the steps. So the checkout GitHub Actions is going to be this one. The setup.net is going to be setup.net. The resolve project dependency is a raw shell command. And the run Azure Functions is using a specific Azure Functions action that is available. So all of this together builds up to this sample workflow that will allow you to deploy your application. So let's see where our main YAML is at. So we're at resolving dependencies, but we're going to give it a few minutes. But at the end of this, what's going to happen is our code here is going to be automatically deployed. So the last step that we're going to have to do is we're going to need to create a little bit of change in our code to make sure that we can actually deploy something new. It doesn't need to be anything amazing. We can just do log information, and we can add the event grid event, and maybe add the event type right here. Or even better, we can just append it right before. So you could do this kind of weird string concatenation, but what I like to do instead of doing these kind of things is using something called an interpolated string. So if you're doing this that way, we will offer you a refactoring. So in this case, we're using the $ double quote to basically paste those events together. So now we don't need a toString. We can just simplify the interpolation, and we're all good. So in our code now, the only thing we need to do is we need to actually push this change. So let's just do a git status, and we have this code. So let's add our code to our staging environment, and then we're going to commit this code by basically saying enriched logging information. All right, so before we push, I want to make sure that we are completely done. The job has been complete. We have processed our application. Our application is in the cloud. We're able to run it. So now let's push, and let's keep an eye on our action. I want to make sure that I see a new one right here. So I'm going to press enter. The code change is going to happen. All right. Let's do a git pull and git push. Main reason for this was because we changed the file directly on on GitHub, so the merge kind of didn't work exactly how it was supposed to. So we pushed our change, and now let's refresh this page here. You can see here our branch has been applied automatically. So what's just happened here is that without any extra cost, we're now having a completely CI/CD environment. Every time we change our code, every time we change our function, this code was going to automatically update and automatically deploy on Azure. You don't need to have the developer's machine available for you anytime to deploy this application. So now we are following best practices in terms of deployment. All right. So that's pretty much it for this demo.
So what did you cover? Well, we managed to connect Event Grid to Azure Functions and basically react to any cloud-focused events. Then we built workflows in code that cover many different patterns, and we showed you how to do cognitive services with the HTTP API async pattern. But we also covered a whole bunch of different ways that you can use serverless to enhance your business. And finally, we went through how to deploy through GitHub Actions continuously your Azure Functions on the cloud so that you're not always deploying from the same machine, or you don't rely on the same machine to deploy everything. So everything that I've done today can be found at our docs. So if you want to get the same information that I provided today, or you want to explore overviews or tutorials or the many code samples that we have, just head out to docs.com and you will have more information that can be found in my session today. All right, and finally, I would love to say thank you to everyone who took the time to watch this video. You're among the few that will see this final slide, and for this, I thank you very much.